Okay, excellent. Thank you again, the Mecklenburg County Beekeepers, for hosting this second of what I hope to be many exciting webinars through this Cooperative Extension Illuminate software package. This is a new format that we're all trying to get used to, but with almost 20 different county chapters of the NCSBA and 94 active participants, live participants, I think this has a lot of potential for beekeeper education and discussion amongst our beekeeping community. Now, several months ago, as we were planning this particular webinar with the Mecklenburg County Beekeepers, we thought we were discussing about what would be a really good, timely topic for the month of January in North Carolina beekeeping, all the way from the mountains all the way down to the coast. And one thing that tends to be very common, a common issue of beekeepers, no matter where you are in the state or really no matter where you are in the nation, is what to do as you're coming out of winter. So the things that you really need to be cognizant of as far as management practices go during this time of year, because coming out of winter can be among the most tenuous times for a honeybee colony, and can result in the largest winter losses that one experiences throughout the year. So with just a little know-how and a little discussion, we're going to explore some of the ways that you can help improve colony survival and productivity coming out of winter. Now, this graph right here will start with kind of the bad news, which is the winter losses of honeybee colonies nationwide over the last 5 years or so. And what you'll see is that the average loss of the entire honeybee population, there's about 2.4 to 2.6 million beehives managed nationwide, and fully 30%, give or take 5 or so percent per year, tend to die over the winter. Now, if you poll beekeepers, and beekeepers have been polled in various studies, most beekeepers say that, well, anywhere between 5 to 15% is okay, it's acceptable losses for a particular beekeeping operation. So clearly the point here is that winter losses in the last few years have far exceeded what most beekeepers say is acceptable. Now, the reasons for this, I mean, I like looking at myself, folks, but I don't know, that's I think a bit too much, don't you think? Let's not boo. Yeah, let's try not to post my face more than we need to. But I guess the point here is that the winter losses are very, very high historically, and they don't seem to be getting a lot worse or a lot better, but they seem to be at this rate that's about 5 times higher than what most beekeepers want. And the reason for this is that colonies die during the winter because it is such a fragile time. Obviously, the weather is not conducive for them for foraging. They are more susceptible to disease and the elements, and so it's not altogether surprising that this is the period of the year when most colony losses happen. What I'd like to impress upon you is that the late winter and early spring is really that critical time for colonies, and that's a real time where a beekeeper can step in and help save a colony that otherwise might not be able to make it all the way through to the following spring. Now, in all of your beekeeping courses and all of your textbooks and in talking with other beekeepers, I'm sure that you've heard many different adages and many different rules when it comes to beekeeping. And when it comes to winter preparation in particular, there are several things that tend to run true, or that you tend to get the similar advice from many experienced beekeepers. One is to take your winter losses in the fall. Now, what that really means is that you don't want to go into winter with colonies that really don't have a high likelihood of making it to the following spring. It's much better to take colonies that may be weak and unite them together, or unite them to a stronger colony, so that that entire unit has a much better likelihood of making it through the winter. So taking your winter losses in the fall means you may be reducing your total colony number prematurely, but what that enables you to do is ensure the survival of that colony, and then perhaps the following spring be able to split it back into two. Rather than trying to go through the winter with two weak hives and then they both don't make it, and then you have no bees in either. So that is definitely an adage that one should think about as you're going into the winter months. Another adage that you've probably heard before is that bees don't freeze to death, they starve to death. Right? We're going to talk a little bit tonight about how this is really the case, that supposedly as long as bees have sufficient honey stores in the combs above the brood nest, that latter part being very important, then the bees will always have some sort of energy reserves so that they're able to generate heat and therefore not freeze. So that's where that adage comes from, and again, we'll talk a little bit more about that. One other thing that's really, really important to keep in mind is that in all the textbooks and in all the bee schools, we all learn that bees live, or worker bees, live an average of about 6 to 8 weeks during the active season. Well, there's a huge caveat to that, and that is workers can live far, far longer during the winter months. That worker bees can live for up to 6 months in some cases if they're not actively working, if they're not actively flying. So the shortened lifespan of worker bees is really due to them being in the active season and literally working themselves to death. Whereas in the winter, when they're quiescent and they're in the winter cluster, they can live much, much longer. They're physiologically very different, but at the same time, they can be much more susceptible to different stressors, particularly parasitism and nutrition. So that, again, going into the winter, if the bees those winter bees are not of high physiological quality, then that might have significant impacts on their ability to survive the winter. This particularly comes true when it comes to varroa mites. That heavily parasitized bees, those winter bees, if they are being reared with heavy varroa parasitism, then their physiology is forever affected and can really lower their lifespan through the winter months. So it's really, really critical to make sure that varroa is in check going into the winter. Okay, so what happens to the honeybee colony during the winter? We probably all know that the bees don't die off, that they survive as a group. They supposedly evict all the drones, right, kick them out because they just eat all the honey and they don't provide any work, right? So the workers evict the drones and they maintain themselves as adults in a tight cluster inside the hive for the entire winter. Now, what they do inside a hive such as this, where they cluster together, and the formation of that cluster actually changes depending on the ambient conditions. And what research has shown is that when it gets to be, it's not really cold as far as we're concerned, but to the bees, they start to get cold at about 64 degrees Fahrenheit, where they actually will start to cluster very loosely at those temperatures, but they will start to cluster as warm as 64 degrees. At around 50 degrees, and that's a real minimum, it's probably a bit higher than that, they'll stop foraging. They just simply won't have the temperatures for their wing motor muscles to be able to maintain flight. So all foraging activities will stop, and they start to cluster. Now, as the temperature decreases from there, the bees huddle closer and closer and closer together so that they conserve body heat by reducing the surface area of the cluster to the overall volume of the bees. So just like we huddle together to maintain warmth, that's exactly what the bees are doing. That they get closer and closer together to minimize heat loss. And they do that down to about 14 degrees when that cluster reaches its maximum density and they just simply can't get closer to each other at all. At that point, what the bees then do is, in addition to retaining heat and minimizing the loss of heat by clustering, they then also start generating heat. They start generating heat by literally shivering. What the bees do is they exercise their wing motor muscles, and in doing so, just like us running in place, you start to to heat up and get into a sweat. That's exactly what the bees do. They will start to shiver, generate heat, and then that heat then radiates throughout the rest of the cluster so that the bees maintain a certain level of temperature so that it's not fatal to the whole group. Now, if the cluster itself gets down below minus 20 for a prolonged period of time, even their heat retention and their heat generation is insufficient for them to be able to survive. But again, as long as they have honey as a food source, that is the energy source that they use in order to generate that heat and to maintain the cluster temperature. So this is why it's really critical for the beekeeper to make sure that they have sufficient honey stores above the cluster going into winter, because that cluster starting out down below will tend to want to move up and laterally in the nest, uncapping and then consuming the honey as they move. So that cluster will slowly move through the combs that have the food in it, so that by the end of the winter or around this time of year, that cluster is moved from the bottom brood box to the top brood box, whereas all the honey in the bottom brood box is now gone, and so the cluster is now up in the upper brood box where the remaining honey stays. So it's often seen, if you start out the winter cluster in the top and expect them to move down, oftentimes the bees don't do that. They're just reluctant to move back down. Even if there's honey down below, they're more reluctant to move down. Part of that is probably because heat rises, and it just makes a lot more sense to go up. So making sure that the honey stores are above the winter cluster is really, really critical. Another thing that can sometimes happen, and beekeepers don't have nearly as much control over this, is that the cluster can sometimes split. If the cluster starts out in the middle and they move up, and then they start to move laterally, one part of the cluster can go one way in the nest, the other part of the cluster can go the other way, and then you have two separate clusters that don't have sufficient mass in order to survive, and the colony can actually not generate enough heat. So that's something that can happen, although it's fairly rare, and again, not all beekeepers are really able to overcome that. But again, understanding the winter behavior of the clusters is really helpful for beekeepers to help the bees overwinter successfully. Now, another thing that you'll read, especially in a lot of the older books and literature, is, and this is also particularly much more true further north in more severe winters, more than North Carolina, is that something that you need to do every winter to every hive is to wrap it, to give it a thermal blanket in some way, and facilitate, their heat retention. So again, as a little means of audience participation, I'd just like to poll everybody who's on here just by the check mark or the X mark, how many people wrap their hives during the winter? I'll give you a few seconds here in order to voice your opinion. Couple more seconds here. Okay, I'll just go ahead and publish those results. I think as you can see, it's pretty clear. Not too many North Carolina beekeepers wrap their hives, and that's really good in the sense that this type of activity is really not necessary for beekeepers in our area. The winter is not nearly as severe as what would warrant having to wrap your hives. I think it would be an overabundance of caution in order to do so, and in fact could introduce secondary problems that would be worse than the cure. Specifically, ventilation is really critical during the overwintering. The cluster, especially when they're metabolizing all of that honey to generate the heat, one of the byproducts of that is water vapor. So if the water vapor doesn't have a chance to disseminate, and there isn't enough ventilation inside the hive, even in the winter cluster, what can happen is that you can get condensation and moisture on the inner combs, and then if that freezes, that can be very problematic, or it can start growth or other problems. So making sure that there's ventilation is often much more important for us in North Carolina versus wrapping. So there's your breakdown as far as how many people wrap, and I agree. I don't really think it is a question down here to wrap your hives. Now, as I said before in the beginning, this time of year where we're coming out of winter and we're just starting our spring management, this is among the most tenuous times for a honeybee colony, and so we need to be very, very careful, but we also need to project and see where we're going into the spring for our management approach. And so for the rest of the time here, what I'd like to talk about are the different things that you need to do looking forward coming out of winter. And that is, what do we do as far as spring management is concerned? And the way I like to think about it is that your spring management can be broken down into three different phases of the spring. Your early spring, your mid-spring, and your late spring periods. Now, of course, the calendar dates of this are going to vary depending on where you are. If you're up in the mountains, it's obviously going to be a little bit later. If you're down on the coast, it's going to be a little bit earlier. If you're joining us from Wisconsin or Michigan, I think there are some out-of-state guests with us this evening. That's obviously, depending on where you are in the country, that's also going to dictate when these will fall on your calendar date. It's also going to change from year to year. Right now we're having an unseasonably warm winter, and so we expect to have an earlier spring. So keeping that in mind, really let the bees dictate and let the weather dictate when these different phases come about. But regardless of when it is on the calendar, the intents and the management goals for you as the beekeeper during these different phases are quite distinct. And so in the early spring, it's really a very quick operation. You don't want to, you're just really triaging different major problems that could occur, and you just want to ensure that they're going to get over that hump and that you're going to have healthy colonies that are starting to raise brood, they're starting to rear brood. For the mid-spring, however, the temperatures are going to be warmer, things are really going to be ramping up much more significantly, and so your goal as the beekeeper is to really promote that colony growth, but at the same time, don't let them grow so much that they're going to want to swarm. So that delicate balancing act, that razor's edge that all beekeepers have to walk, of trying to have the maximum colony size but not having them split apart. And then finally, if you've done all of those things right, then hopefully your late spring management is really all about maximizing that honey flow and that nectar flow. You want to super your hives. You want to try to maximize your honey production during that late phase. So we'll go through each of these in turn, not really focusing on the late spring and honey production, but really focusing on this early spring and the mid-spring techniques that you'll need to accomplish as a beekeeper coming out of winter. Okay, so in the early spring, that first initial spring inspection. Some of you may have already done this as far as spring or one of these kind of midwinter inspections. But this is a really critical thing that you need to do to hedge against struggling colonies and just, as I said, trying to make sure that they get over the hump. Now, oftentimes in these early springs, it's still usually cold during these inspections. So that means that you want to try to minimize going into the hives as much as possible. They're still trying to retain heat. They're still trying, in some cases, to generate heat. So the longer that you have that lid open, the more frames that you pull out can be quite disruptive, unusually disruptive to the colony during that inspection. So you really just want to be quick get in, quick get out, and just make sure that the colony is doing well for this early spring time period. In particular, what you want to look for is the queen. Look for the queen, or more precisely, look for evidence of the queen. Is there brood? Are there eggs? What stages are they? If you only see eggs, then you know that the queen has only recently been laying in the last 3 or 4 days, or at least that the workers are not starting to raise the larvae, to feed the larvae with brood food. If you see eggs and larvae, then you know she's been laying for at least a week, and they have enough protein stores to be able to nourish those larvae with brood food. If they have capped brood or even emerging brood, you know that the queen's been laying for at least 3 weeks, which is a very good sign, and it means that the colony is starting to replace the dwindling population that has been slowly dying off through the winter. So understanding the brood pattern during this initial inspection with a little practice can be done very, very quickly. A quick and dirty way to see how well the colony is doing, at least as far as the population is concerned, is doing what's called a cluster count. Now, Don Hopkins and the other apiary inspectors will tell you that they rely on this a lot, and they are very, very well adept at determining the strength of a colony based on its cluster count. This is where it helps to have colonies in double deeps, or at least in 2 boxes, where what you can do is just split the boxes apart, lift the top one up and look underneath, and then count the number of frames that have bees adhering to them. And so if you count 7 frames that have bees on them, that's kind of the diameter of the cluster, that sphere of the clustered bees, and then that will give you a cluster count. And so it gives you a very good, albeit rough, idea of what the population is in the colony. Again, coming out of winter, you really hope to have at least a cluster count of 4 or more if the colony is going to do well. I might be wrong there. Don or somebody might want to correct me on that, but making sure that the cluster count is sufficient for the hive size. Another thing that's really important this time of year in the early spring, late winter, early spring, is that the honey stores become incredibly critical. It's still cold out. They still need honey stores. They still need that energy reserve to generate heat and to start feeding the new brood that is being reared. So if they don't have enough honey, they can be in real trouble. And this is the time when the bees are most likely to starve to death. So making sure that a colony has at least 30 pounds of honey, again, preferably above or just adjacent to the main cluster, is really, really critical. If they don't have that, that's where you need to feed supplementary sugar solutions, sugar syrup, if they don't have that. Preferably, that's only in a real triage situation where they're really dry and they barely have any honey. That's necessary. Hopefully, you've planned ahead well enough where they're going to have sufficient honey stores. However, still, you can do everything right and still things go wrong. And so you also want to then identify any colonies that have died out, and you want to remove those dead outs from the apiary before temperatures get warm enough where foraging can resume. And worst case scenario is that the dead out colonies get robbed out by other colonies in the apiary, which could help spread disease and cause lots of other problems. So you want to remove that equipment from the apiary. You then, once you have it in your garage or wherever, you want to inspect it very, very closely. You want to identify as best you can the cause of mortality. Was it due to disease? Was it due to starvation? Was it due to a bear? Was it due to, whatever factor you can try to attribute it to? If there's any doubt, make sure you call your apiary inspector to help you diagnose and identify the potential problem. And by all means, if there's any suspect of American foul brood in particular, do not use that equipment again until you have verified the reason why that colony died out. That itself is among the most noxious diseases that is highly, highly transmittable if you reuse equipment. So it's another thing to do during these early colony inspections. Now I'd like to poll the audience again really quick, learning what we just discussed as far as the early hive inspections. This is a picture that I borrowed from Dewey Karen, who asked a similar question in his presentations, and I think it's very, very appropriate. And the question is quite simply, is this beekeeper here using good technique for an early spring inspection? Why don't we go ahead and vote here, again using our check for the yes and X for the no tools. Give you a couple seconds here. Wow, you guys are on to me. I'm making my questions way too obvious. Okay, well, none of you fell for it. All of you, of course, are saying that this is not sufficient technique, and you're absolutely right. Can somebody chime in there, perhaps, and give me an answer as far as why, or what's some evidence here that leads you to believe that this person is not doing an adequate job at her early inspection? Anyone? The bees will be angry. Okay, that will be true. The lid is wide open. Yeah, exactly. Well, that might not be a problem if it's you know, 70 degrees out. What leads you to believe that it's not 70 degrees out, that it's perhaps less? Yeah, yeah. Look at the winter jacket she has on, right? I mean, it's clearly quite cold out, and you know, not only is this not a quick inspection, they're sitting down on the bottom board with the jacket, has a frame out, and you know, going through with the Hive tool, counting, you know, a really close inspection of that comb. Those bees are getting very, very chilled. That's pretty obvious. And so, you know, this is not the best way to go about it. What you're actually doing is introducing you know, a lot more stress as far as the bee's ability to maintain that temperature in the cluster. So yeah, you're absolutely right. Okay, so we said before that colonies that are light when it comes to honey stores this time of year, the early winter, sorry, the early spring, late winter, early spring, it might be necessary to provide those bees with supplemental syrup. Now, this can be done even without opening the colonies and going through frame by frame, which you probably don't want to do, to see how many frames of honey there are. You can do what's known as hefting, which is just simply the process of going to the back of the beehive and lifting it up from the bottom board and tilting it just slightly, maybe just a few inches up, and just gauging how heavy the entire hive is. If you can barely lift it up, then it's going to be very heavy, primarily of honey, and they're going to have sufficient honey stores. If it seems very light, that you're really able to lift it up a couple inches off of the hive stand, then they're no way are going to have 30 pounds of honey, and are almost certainly going to need to be fed. So that's a good way to gauge a rough idea without even opening the lid to see if the bees need to be fed. Then the question, if you do determine that the bees need some sort of sugar syrup in order to make sure that they make it over the hump, and they make it to mid-spring when most things are in bloom, then you have the many choices that lie in front of us beekeepers. Do we use internal feeding mechanisms or external feeders? You know, you have these Boardman feeders that fit into the front entrance. You have these division board feeders that take the place of a frame, but it serves as a reservoir where you can pour sugar syrup into it. You have the inverted bucket that lies right on top of the cluster. You have the top hive feeders, which can hold many gallons and has kind of an internal entrance into the feeders. So there's lots of different options out there. And really, again, this comes down to beekeeper preference, what you have, what you prefer. But what I like to, what I think tends to be preferable is something where the bees have close access to it and it's above the cluster, rather than remote access like one of these you know, front feeders where it's below the cluster. So they're less likely to be able to take that feed, or at least as rapidly, if it's below and far away versus above and on top. So I think that's just one general rule that's good to help out the bees. Another thing. So here's a question here that's it's often said that you should not feed syrup in the winter, that it should be dry granulated sugar or candy. Is that true? Well, I don't know if there's really a true or false answer to that question. Again, I think that comes down to beekeeper preference. I think the reason why it's said that dry sugar is better than syrup is that if it's in syrup, the bees still need to evaporate the moisture out. And if it's extremely cold, then they're really not going to be able to do that very well. So it might be harder for them to incorporate that. But I think if they consume the syrup and then use that directly as the energy source, then it's not quite as bad. So I wouldn't say that that's right or wrong, but again, it's up to beekeeper preference. Now, one thing, and the Hope County group kind of touches on this here in their question, is the formulation of feeding. You can have a very dilute sugar water syrup, or you can have a thicker one, or you can even have a solid one in the form of fondant or candy that you can provide, or the granulated sugar that you can provide them. So again, there are these many options, and again, it's important to recognize the reason for feeding during this time of year. If the bees are very light and they don't have a lot of honey stores, then you probably want to err on the side of having the supplemental sugar being as thick as possible so they can get the most energy per volume. Something like 2 parts sugar to 1 part water is probably the thickest, or if you can get it thicker than that, the thickest liquid syrup, or granulated sugar or a fondant would help as well. If they have sufficient honey stores, a thin sugar syrup can actually help stimulate egg production and egg laying by the queen. So if it's kind of later, closer to mid-spring, things are really about to warm up, then feeding a thinner syrup can help stimulate a nectar flow, and that can actually get the bees to start raising brood where they might not have otherwise. So again, it kind of depends on the intent of feeding during this time of year. Another thing to add, I really won't go into this very much, but you know, if in feeding sugar syrup, some beekeepers like to add antibiotics or other additives. That's another option that's in front of you as far as whether or not this is the time to do it. But again, remember the intent of it. Are they really light on honey stores and you want to make sure that they can generate enough heat, or are you feeding them in order to stimulate oviposition? Those are the different calls that you need to make during these early spring inspections. I won't go into the feeding. I see that there's lots of questions here about nutrition and feeding, and it really is a critical issue. And I'm not going to delve too much more into it than that. But I do encourage everybody who is interested, and even if you're not interested, this is information you probably should know. And there's a really nice, albeit fairly long, it's a very extensive publication called Fat Bees, Skinny Bees. And it's published out of New Zealand. We'll forgive them for that, but they have done a very nice job at reviewing a lot of the apiculture science dealing with honeybee nutrition and all these different techniques that you can help augment the bee's diet when they really need the helping hand from the beekeeper. I can send around this link afterwards if you want. I'm sure if you do a quick Google search for Fat Bees, Skinny Bees, it'll come up as a PDF that's free for download. Now, after that early spring, that's kind of getting over the hump. And after that point, then any colonies that don't make it, I would say it was not from winter losses, but rather, spring losses. So hopefully the hard part for the colony is over once it starts to warm up, and once, oh, thank you for that link there. Terrific. And it's no longer free. Shoot, that's too bad. Well, it still is an excellent publication. Whatever it costs, I would highly recommend it. But once things warm up, once things start blooming, this is when your intent as a beekeeper really starts to change. And this is what denotes the mid-spring versus early spring. The mid-spring is really trying to promote colony growth and trying to minimize swarming so that the bees stay in your boxes. So this is where your inspections can be a little longer. The temperature is more favorable so that you you can really go through frame by frame and do a thorough inspection. You want to look for disease. You want to look for the queen laying pattern. A real thorough inspection at this point of time will really help the trajectory of that colony down the line. Again, you really want to look at the queen and her laying pattern. If you don't think that the old queen that came through the winter is sufficiently laying, if her egg laying pattern is kind of scattered or spotty, or it's not quite as many frames of brood as you think that it ought to be for that time of year, then requeening is a really significant option before the colony gets too far into the spring. Again, just like taking your winter losses in the fall, you can also make sure that you ensure colony productivity by uniting weak colonies using the newspaper method. For those of you that haven't used this before, this is a real standard, tried and true means of uniting a weak colony on top of a larger one, or uniting two colonies together. Now, we all know that colonies recognize each other, or the members of the colonies recognize each other by smell. And so if you just threw two boxes together, the bees would recognize of the two colonies, would think of themselves as foreign and start to fight and kill each other, and then you'd have a big mess on your hands. So a way to get around this is, again, understanding the bee biology in order to trick them into thinking they're of the same colony. And the way to do that is you take the one colony down below, and you lay a single ply of newspaper on top of the top bars, and then place the other box of bees on top of that. Now what happens is that newspaper serves as a barrier so that the bees can't interact and fight each other, but it's porous enough where the newspaper allows the odors of the two hives to intermingle. And what happens is the bees start to chew that newspaper apart and then slowly start to be integrated with each other. They start to smell like each other, so they don't recognize themselves as friend or foe. So it's a way to kind of time release and slowly introduce the two populations so that you don't have you know, kind of a mass mortality on the hand. There's a question about do you want the weaker hive on the bottom or on the top? Let's do a quick straw poll. How many people like to put the, if you have a weaker hive and a stronger hive, how many people like to put the strong hive on the top versus on the bottom? So if you like the strong hive on the top, check yes. If you like the weaker hive on the top, check no. And I'm going to stay out of the voting so that I don't corrupt anything. Okay. Yeah, I personally, and this again, people can chime in here and disagree with me if you wish, but I personally like to put the weaker hive on top, because again, as we'll learn in a moment here, the brood nest, it really is good for them to be moving up. So if there's more space for them to move up into, if the weaker hive is less populous and there's more empty frames on top, that can actually help promote colony growth after they're united. But again, that's just a beekeeper preference, and I'm not entirely sure if there's a right or wrong answer there. So this is kind of what I was just talking about, and a good segue into that. As a colony is coming through winter and coming through that early spring where they have sufficient honey stores, there's still not a whole lot of honey left inside that that hive, and in fact, down below the lower brood box is primarily of empty comb, right? So here you have the cluster here, any remaining honey up there. They're starting to grow, they're starting to expand now that it's mid-spring, but there's all this wasted space down here. And again, the brood nest, for some reason, the queen really likes to move up in the brood nest rather than down. I mean, she will move down into the brood nest, but for some reason there's a preference for them to move up in the brood nest. So a simple reversing of the two boxes, or even frame by frame, where you place the main brood nest and the queen and the main population of bees down below, and then empty space for her to move into and start laying and for the whole colony to start growing into. That really helps stimulate brood rearing and nest expansion so that the colony will start to grow faster than it might otherwise. So this reversing technique is really, really helpful for the beekeeper during this mid-spring time period for colonies that are coming out of winter. Not newly established colonies, but colonies coming out of winter. Now, again, the razor's edge that all beekeepers have to walk is stimulating as much growth and brood production and as high a population as you can manage, but the natural tendency of the bees, once they get overpopulated, once they have a lot of brood, they start to decrease their ability to circulate the queen pheromone that helps to regulate the colony and keep them cohesive. The result of that lack of queen pheromones circulating through the colony is that it triggers swarming, that they start to raise queens, and then the mother queen will leave with a good 75% of the adult workers, and then leave for another colony, leaving behind a daughter queen. This has a huge impact on the productivity of the remaining hive, and pretty much you just lost your honey crop. So this is something that every beekeeper really tries to hedge against, is to see that happen, to see your bees leave into the trees. So knowing what causes swarming, that overpopulation and that brood nest congestion, what the beekeeper can do is try to promote that colony population buildup and that colony growth, but minimize those triggers that make the bees swarm. So the way to minimize the swarming is to reduce that brood nest congestion while still promoting that colony growth. Adding more boxes, adding more space, adding empty frames to the brood nest, reversing and rearranging the frames strategically so that the queen thinks that she's not being that she's not running out of space, and that she still has plenty of combs to lay in. And another thing too is that this is a great time to make your own splits and to take a very strong colony and make new colonies from it, knocking back a strong colony, not so much that you've lost your honey crop, but knocking it back so that their tendency to swarm is a lot less. So all of these things are good techniques to do. The way to go about it during this mid-spring time period is that you want to go into your hives once every 7 to 10 days. And that is because the development time of a daughter queen is about 16 days from the moment the egg is laid to hatching. So if you go in every 7 to 10 days at the most, you're going to go do a careful inspection each time, you're going to be able to see any queen cells that are developing and hopefully be able to stop the bees from swarming before those queens fully mature and the mother queen departs. So I'm sure all of you know what the queen cell looks like. It's these kind of peanut looking cells that hang vertically downwards. They can also be on the bottom of the frames in between two brood boxes. That's a very common place for them to find. And the old adage, if you go to the bee books, is that there's swarm cells in one particular location, and then supersedure cells are those cells where they're just trying to replace the queen. They're not trying to split in half, or on another location. So I'm going to do another quick poll the audience here. Is how many people think that the swarm cells are on the left? Do a check mark. And if you think that this is a swarm cell right here on the right, do the X. Well, excellent. I'm going to have to agree. You guys have obviously all done your homework, and/or you've read the appropriate textbooks. That's what the textbooks say, right? Is that the supersedure cells are those that tend to be in the middle on the face of the combs, whereas swarm cells tend to be on the periphery of the combs, hanging down kind of like cow udders. And so a good way to check for swarm cells is if you crack, and you don't have enough time to do a real thorough inspection, is you go and you crack the brood boxes apart and you look underneath the bottom frames, the bottom bars of the frames in the top box. And if you see any queen cells hanging down, then you know that they're not just in the process of swarming, but they could have already swarmed. And so it's you need immediate attention if that is indeed the case. If that's the case, then as I said, it's almost too late, and you have a real triage situation on your hand where you want to really reduce the congestion within that colony. Otherwise, they are going to swarm. Now, the first thing you want to do is you want to try and find every single one of those queen cells, and you want to cut them down to prevent them from following through on the whole process. But really, that's just treating the symptoms. It's not going after the cause. The things that you want to do are try to reduce that brood nest congestion so that the bees don't want to swarm. They don't want to raise queens in the first place. Now again, one good way to do that in the mid-spring for swarm prevention is reversing. We said before how the queen and the brood nest likes to go up in the column of the combs. And so over time, what happens, you have a very nice large brood nest here. The queen's laying in the upper brood box. Most of the brood in the lower box here is all capped. And so what happens is that she starts to run out of room, in which case there's that brood nest congestion, and that's a real trigger for swarm preparations. So again, if you reverse these boxes where you put the open brood, the young larvae, and the eggs down below where the queen is, and then the capped brood in the upper box, in the upper brood box, what happens is that over the next week or so, that capped brood starts to hatch out. As it hatches out, that frees up comb in the brood nest area so that the queen now has space to lay above, and she's still able to move up in the brood nest. Okay? So it's a way for them to continue maximum brood production and colony growth, but it kind of lowers that congestion within the brood nest because the queen still has a place to lay and a place to move into. Now, if you do find swarm cells and you do have a real triage situation on your hand when it comes to swarming, a real effective way to knock back the colony is through checkerboarding of frames, where under real congested circumstances, what you can do is you can take out every other frame of brood, put it into a nuke box, put it into another weaker hive, do something with that brood, and then replace it with foundation or empty comb. And so now what was, 7, 8 frames of solid brood and very, very congested, now by checkerboarding every other frame is empty, and now the bees, they're not nearly as congested, and that significantly decreases that tendency for the bees to want to swarm. So again, these are all techniques that you can use to try and have your cake and eat it too by maximizing colony productivity, but minimizing the bees' tendencies to swarm. Now, one of the most effective ways is to make a split. That is to actually take 5, even 10 frames out from a very strong colony, and that will significantly decrease the tendency to swarm, because in essence you've just made them swarm. You've split it in half on your own. The difference is that you now have 2 hives rather than 1 hive and then another one in the trees, right? So by being proactive and splitting the colonies yourself, you can grow your apiary populations, you can replace colonies that have died out over the winter, and this is a way that you can grow your own operation. Now, if you're taking one very strong hive, it's often a good idea to try to make the splits equal. You can take one strong hive and you can even get 4 splits out of it if it's very populous. But you want to make sure that they're relatively equal among the different subunits, so that each one has an equal chance of growing to its maximum potential. The way to do this is you want to try and find the queen. It's not absolutely necessary, we'll talk about that in a second, but you really want to do your best to find the queen, so you know which one she goes into. Does she go with the split, or does she stay back with the original colony? If you do find the queen, you want to take the half that has the queen in it, with, again, all stages of brood, with enough food, and in both of the units. You take that queen right half and you want to move it at least a mile to another site so that the foragers from the split do not return back to the original nest site, right? So you want to move it away, at least temporarily, with the queen. And then, of course, you want to requeen the queenless half of the split 1 to 3 days later, and in doing so you might need to go into the colony and tear down any of the queen cells that they've started to construct on their own, because again you've taken the other queen away. Sometimes it's best, in fact, to make sure and wait for that new queen to be laying and accepted, and then go through a week later and cut down those queen cells, just to make sure that the requeening was successful. Now, I said before, if you couldn't find the queen, if you're trying to make a split for swarm control purposes, you can do what I call as a dirty split. If you go through frame by frame and you really take each frame and try to make the splits equal, that's a clean split. You're being very methodical about it. But a lot of commercial beekeepers in particular, but a lot of beekeepers do what I call a dirty split, which is where you just take 2 brood boxes and you just take the top one, put it on a new bottom board, slap a lid on it, and then move it away. And then you come back 3-4 days later, you check both hives. The one that has eggs in it is the one that has the queen. The one that has queen cells starting to lay in it and no eggs, that's the one that you need to requeen. So it's just an easier way to be able to make your splits and to decrease the swarming tendency. There's a question here about what's wrong with natural queens, and is it okay for the colonies to make queens on their own? That's kind of a different subject, and I'll give you the short version of it. In short, there's nothing wrong with replacement queens or swarm queens. There is a couple downsides to doing so, where requeening is oftentimes favorable. One is that, again, it takes 16 days for the queen to develop and emerge. It then takes another week for her to become sexually mature. and then probably about another week for her to go mate and store all the sperm that she's going to need and start laying eggs. So you're talking about 4 weeks of no actively laying queen inside the colony, and as a result, the population of the colony can take a significant hit. So by requeening with a mated laying queen, you are jump-starting the colony productivity much more effectively than letting them raise their own. Now, if you're doing this early in the season, you can't find queens, you don't want to buy them, then you might not have an option. But that's one reason why it's preferred. Another is that you have control over the genetic stock, and particularly of who the queen mates with, if you're requeening from a commercially purchased queen, where that's not necessarily always the case if you're letting the colonies requeen themselves. This becomes particularly important, obviously not here in North Carolina, but in areas of the country where it's Africanized or where there are Africanized bees in the feral population, and so that's definitely something to consider as well. So short answer, there's really nothing wrong if that's what you want to do as a beekeeper, but again, to maximize productivity in the requeening half, it's good to have a commercially mated queen or one that you've made on your own, preferably. Now, a lot of beekeepers might tell you of other ways that you might want to cut down on swarming. And so these are some things that might be told to you as a good way to stop swarming, but they actually don't work. And the reason that really none of these work very effectively is that it doesn't, it might treat the symptoms, but it doesn't treat the cause. Again, the cause of swarming is that congestion, and so none of these things really go to abating that congestion within the brood nest. You can clip the queen's wings, and that will prevent her from flying. So the mother queen won't be able to depart with that swarm, and that's true, but that won't, the bees don't know that, so they'll actually usher a swarm, they'll go out and leave, and then the queen will slowly walk along, desperately trying to fly and not being able to, and you'll probably just end up losing that queen anyway. So clipping the queens is definitely not a means of swarm control, because it really doesn't do anything except probably end up killing your queen. Another thing is putting a queen excluder on the entrance. I don't know if anybody here does that. That, I think, is the last gasp of desperation in a way to try and keep a queen in. Again, the swarm will usher out, the queen won't be able to follow, the swarm will just come back in, and they'll just keep doing that, wondering why the queen isn't able to come with them. That queen excluder on the entrance doesn't do anything to get rid of that congestion in the brood nest, and so they're just going to continue to try to swarm just by that alone. If you go in every 7 to 10 days and cut queen cells, again, that's something that you want to do, or at least you want to be aware of. But if that's the only thing you're doing, they're just going to keep building new queen cells until you get rid of that congestion. Same thing with confining the queen. Now, over time, if she's confined for a very long period of time, eventually she's not going to be able to lay as many eggs, and the congestion in the brood nest will eventually free up. But it's going to take quite a long period of time to do that, and it's not going to have an immediate effect. So these are definitely things that you want to avoid, or at least that you don't want to rely on as far as trying to keep the bees in your boxes. Now, if you've done everything right and you've prevented the bees from swarming, but they're still highly populous, and they're doing really well during that mid-spring period, as you go into that late spring phase, the main part of the nectar flow, this is where you can just sit back and say, I've done my job, and I've done it well, and now I'm just going to reap the benefits of all of that hard work in the early and mid-spring. You want to add as many supers as you can as they get filled up. You don't want to feed anything. You don't want to feed any supplemental sugar or anything like that so that it gets incorporated into your honey crop. Definitely no medications, no miticides, no nothing that will get incorporated into your honey. Really, the less you do is the better. You just want to sit back and let the bees do their thing. The more populous they are during this period of time, the more honey that they're going to make. It's a rule within beekeeping biology that one colony of 50,000 bees will make way more than the combined honey of two colonies of 25,000 each. That the more bees in the colony, the higher proportion are devoted to nectar foraging and honey storage and honey production. So the stronger the colony, exponentially more honey is going to be made by that colony. And even doing something as benign as smoking the bees or just going into the hive can, during a real strong honey flow, you can lose 5 to 10 pounds of honey production just by disrupting their honey collection and honey storage, just simply by smoking the entrance. So the less you do, the better during this period of time. But again, I won't dwell on this because really we're talking about coming out of winter, but this just shows where you're headed to during those early and mid-spring inspections. So to summarize, the late winter and early spring, this time of year, or just kind of the next month that we're entering in here in North Carolina, is really one of the most tenuous times for a honeybee colony, and as beekeepers is something we need to be highly cognizant of. Understanding the winter cluster really helps the beekeeper ensure that the bees have what they need in order to make it over the hump. Those early spring inspections should really be short and target those really significant problems, not small problems, real significant problems like not enough honey or a real poor queen or any dead outs. You want to triage those types of things and just ensure that they're going to make it into the main spring season. During that season, your job as a beekeeper is to be more thorough in your inspections and to promote colony growth while at the same time minimizing swarming and mitigating the tendency of them to leave by reducing that brood nest congestion. And then finally, those late spring inspections is really about hands-off approach and just letting the bees do their own thing. Now, before I end here, just have and start to take some questions, I want to make you aware of a couple things. One is that NC State, along with many other collaborative partners here, are part of this effort called the Bee Informed Partnership. I know many of you are actively already participating in this, but this is a collaboration between beekeepers and apiary scientists and officials to try and garner data on the honeybee population, specifically as it relates to winter mortality and other significant issues. So if you go to beeinformed.org, you'll be able to see all of the different activities that are going on here, and you'll be able to contribute to our overall understanding of things like those winter colony losses that we began the discussion with. So I encourage you to participate in that, and the more beekeepers that are participating, the better understanding we'll have about our bees. One last announcement is that I'd like to for you to save the date. That this is the current session right now is our second webinar that we've had in the state of North Carolina. The third is going to be this upcoming June 14th, and much like the Mecklenburg County beekeepers graciously hosted this webinar. The Montgomery County beekeepers, who unfortunately couldn't be with us tonight because of some IT problems, they're going to graciously be hosting us this upcoming June. The topic is yet to be determined. We'll be determining that and then announcing the opportunity in the coming weeks and months. But just if you enjoy this particular format, and I appreciate all 116 of you that have logged on, and the many groups out there, if you like this format, go ahead and save that date and we can start working towards that again this upcoming summer. I believe then in September, I forget the exact date, but then Haywood County is going to be similarly hosting another webinar. So keep posted onto these dates. I'll also be making up a web page on our website that will keep track of these dates, these upcoming dates, as well as links to the recorded sessions for these webinars so that people can view them after the fact. And then finally with that, I'd be happy to try and take any of your questions. And yes, you can use your applause sign if you wish. Appreciate it. Thank you, thank you. Okay, so rather than call on names, I suppose I could call on names here, but why don't I just start reading some of these many written comments that are here. Well, one is a technical one. Are these webinars always in the evening? So far they have been, and since they have been hosted by different beekeeping county chapters, I've been doing them with the normal time that their county chapters meet to make it more amenable to that. Is that something that everybody seems to like, to have the evening webinars, or is during the day actually more amenable? Why don't we again do another quick poll? A check mark if you like having them in the evening, such as this, or if you'd rather have them in the day, do an X mark. Okay. Well, it looks like most people seem to like the idea of having them during the evening. So if that's how people like it, we'll continue that. We might have for example, a symposium or something like that during the day. I think this format is amenable to many different things, so we might try different ideas. But for now, we'll just continue this. Let's see. What is the minimum temperature for the first spring inspection? Great question. I don't think there's an absolute rule there. I just think you want to avoid really cold temperatures. You want to avoid rain and snow. You know, you don't want to go into the colony when you're going to maximize heat loss, right? So if it's particularly cold, if it's particularly wet, it's probably better to not go in at all. If you have a warm spell, that you might be opportunistic and just take advantage of that. I definitely wouldn't want to go in, what would you say, less than 45 degrees, something like that. But again, it really depends on how fast or how long you're in the colony and what your intent is. But clearly the warmer the better. Here's another question. Is nosema suspected to be a big problem this year? Well, that's an interesting question. In fact, it has some bearing really on the discussion here, which is that nosema, the gut parasite that lives inside the digestive tracts of adult bees, is becoming much more of a problem, a management problem, significant disease issue than it had been, say, 10 or more years ago, where it was kind of relegated to a more minor issue. And what the nosema does is it seems that it can help not prevent, but it can make it more difficult for the bees to digest food and to take advantage of eating the honey stores and generating the heat. In other words, it can make it more difficult. It's another additional stressor for them to be able to make it through the winter. That's another thing to suspect. If you see bees with distended abdomens, or if you see defecation inside the hive or immediately outside the hive, these can be signs that they may be have a heavy nosema infection load. In which case you definitely want to contact your apiary inspector. They may, if they see fit, take some samples to be able to determine the level of nosema and to verify the presence of nosema. And it may, again, may be necessary to feed fumagillin or antibiotic in order to clear them of that infection. Again, all beekeeper choice. So whether or not it's going to be an important nosema year, I don't have any means of predicting that. I don't know if Don or any of the apiary inspectors wish to hop in here as far as the Department of Agriculture point of view, but I don't see any reason to suspect why it might be. Oh, and what about the fly? Okay, I should have prepared. I should have put an extra slide in on that because I should have known I would have gotten a question about the fly. There have been a lot of headlines in the last few weeks concerning a kind of newly discovered, within the last few years, parasitoid of honeybees. It's a phorid fly. It's kind of the same species of parasitic fly that has been brought in to try to control the fire ants. You've probably heard of those. This is a different species now. This is something that previously was known to attack bumblebees, but there was a report in the last few weeks that fairly convincingly documented that that they were also able to retrieve them and emerge them from honeybees, and therefore question whether or not this is a new phenomenon that may be of concern. Now, I think it's far too early, and the authors, of course, clearly stated that it's far too early to really say with any certainty whether this is going to be a significant management issue. We still don't know if they're in North Carolina or if this was an isolated incident in California where the study was conducted. We don't know the prevalence of these flies. So a lot more work has to be done. I really have to chastise the media, though, and one pet peeve of mine is that anything that has to do with honeybees and health problems with honeybees, they immediately attribute that to CCD. And you know, there's really no reason to suspect that the phorid flies are the reasons why we have CCD. I mean, those are two totally distinct phenomenon at this point, and a lot more work has to be done. So the short answer to any concern to that is no. Don't worry about these phorid flies until we have a lot more documented evidence that they really are going to be a problem. Here's a question concerning feeding bees in winter. Can sugar candy be dissolved in hot water to dissolve the sugar? And the answer is yeah. That's a good way to reconstitute crystallized sugar if you want to reuse it. The important thing here, though, is that you never, ever, ever want to heat or boil, especially boil, sugar water. What you want to do is you want to boil the water and then turn off the heat and then add the sugar, or pour the water onto the sugar to reconstitute it. The reason is that heated sugar can start to caramelize and change the sugar chemistry. And caramelized sugar can give bees dysentery and make them even more sick. So if somebody tells you, hey, I have a whole lot of molasses, do you want to feed these to your bees? whatever you do, don't take them up on it, okay? Because that will actually make the bees sick where you know, it wouldn't otherwise. So just make sure that if you're going to reconstitute or you're going to dissolve sugar in hot water, heat the water first, then add the sugar after you've turned off the heat. Okay, here's a good question coming out of winter. I overwintered a small colony in a single deep. How early should I add the second deep? So that's a good question. Obviously, the cluster within a colony like that, or within a hive like that, is going to be smaller, right? You have to be extra vigilant about making sure that they have honey that they're able to eat in that cluster, because they're only going to really be moving laterally rather than being able to move up or over, right? But once you hit that kind of mid-spring, maybe even early spring, the colony is sufficiently strong, you can place on that second brood box and then promote the colony growth, just as you would coming out of winter like this, where that lower box is totally empty, right? So in essence, this colony is only in one box too, right? So it would just be like this, where instead of reversing, you just be adding on that empty brood box. Now, another thing that you can do, rather than just putting all 10 frames of empty comb on top, you can even split the difference, where you can help facilitate them moving up by taking a couple combs out of the bottom box and kind of seeding them and putting them in the middle of the top box to help help them channel upwards. It's just another thing that you can do to help stimulate growth. Let's see, lots of other good questions here. I was thinking of regulating the hive temperature with a temperature-controlled heater. So what's the optimum internal hive temperature? Well, that's a really good question, and in some places they do that, or they move the bees inside. This is places like, you know, Minnesota or northern Alberta, you know, really severe winters, right? Here we probably don't have to do that. Unless it's excessively cold, and it's usually not really needed. The bees can take care of themselves for the short winters that we have here in North Carolina. Now, the downside to possibly keeping the bees warm is that the warmer they are, the more honey they go through. Right? This is another reason why it's kind of tenuous right now with the warm, unseasonably warm winter that we have been having, is that the more active the bees are, the more they're going to eat, not for heat generation, but just for starting to raise brood, or for taking cleansing flights, or you know, scouting flights to see if anything's in bloom. And so they can actually, the warmer they are, they can actually go through their honey stores faster. Rather than saving them honey by providing them warmth, you can actually do the opposite. So it's something that you need to be very careful of in providing them extra heat, and really should only be done if it's just, you know, unspeakably cold outside for a prolonged period of time. So here's another question. When the hive swarms during the 4 weeks when it's queenless, will the varroa mite population be reduced? That's a very excellent point. Is that you know, swarming is bad for your honey production and for your hive population, but it's not necessarily all bad. It's actually, swarming is a natural way for bees to purge their parasites, and varroa mites being you know, one notable case of that. The new colony that is being established by the mother queen they'll be taking varroa mites with them in the phoretic phase, but maybe a lot of them will get knocked off. They might not have enough time might not be able to cling on long enough for them to be able to reinfest the brood in the new nest. So that's actually beneficial for that colony. For the one left at home, if there's that hiatus of brood rearing and there's a big window where there isn't any new hosts in order for the varroa mites to infect, yes, the population can crash when that occurs. So there is a plus side to that, and if that's a mechanism that you'd like to employ in your management techniques to try and knock back the varroa mites, then so be it. But just realize that there's a consequence when it comes to honey production and other aspects of colony growth. Another question here. Check my hive this week for honey, maybe 10 pounds gone, but it's still a strong hive since this fall. Strong hive since this fall. Is this the result of winter feeding? Well, it depends on how much you fed and when you started and how much you gave them and what they did with it. It's definitely something that in going into winter, again, you want to make sure that they have sufficient honey stores, especially above that brood nest, to make it sure they go through the winter. And if you live in an area where most of us do in North Carolina, where there really isn't a great fall flow, where they can really tank up on something that will allow them to get through winter, you might have to do some feeding in the fall for them to be able to pack it into the honeycombs so that they'll have it this time of year. If honey is available, will bees take sugar syrup? That's a great question. I guess if they want to, they will. If they don't want to, they won't. It's kind of inexplicable. Sometimes, the bees will take it. Other times they won't. My philosophy is that if you give them this sugar syrup because you think they need it, and they do take it down, keep giving it to them. If they don't, then stop. Oftentimes the bees will tell you their needs, and if you can just respond to what you think they might need, then help them out by providing it. If they don't take it, then they're telling you that it's probably something that they don't need. Another question here is, when in spring do we put in the drone frames? That's a great question. Again, that's really beekeeper prerogative as far as what you want to do. A lot of beekeepers like to, well, there's a nice shot, holy cow. A lot of beekeepers like to keep the drone combs in year-round. Drone comb makes fantastic storage vessels for honey. They're bigger pots, they're bigger cells, and so there's really nothing wrong with that. It's often on the periphery of the brood nest, so that's where they want to store honey anyway. So there's nothing wrong with keeping drone comb in, year-round. But it's usually probably in the beginning of that mid-spring inspection is when you want to place those drone combs in, or really once they start kicking up the drone rearing. If you go in one of the early spring inspections and they're really at a head start in their brood production and their population is high, then that might be a good time to put in the drone comb if you want to boost the drone population. Otherwise, you want to wait until there's at least a cluster count of 6, 7, 8 before you put that drone comb in. So another question here, does feeding in the fall, fall heavy, keep the queen laying hard, thinking there's a flow on? I had the hardest times getting my hives to wait, but fed copious amounts of sugar. Well, I think we've all been there. This is again where the intent of the sugar feeding is really important to know. A thin sugar syrup helps to stimulate oviposition. So a 1 part sugar to 2 parts water is closer to the sugar content of nectar. And again, that tends to be an external stimulus for the queen and the colony to really start raising a lot of brood. Conversely, if you have a very thick sugar, 2 parts sugar to 1 part water, then that's going to be thick enough where they're not going to have to evaporate as much water off, and it will go into the combs much easier, and they'll be able to store it as honey in much the same way that they would use it as honey than it would with a dilute sugar. So yeah, so a thicker syrup in the fall is preferable, and then to stimulate oviposition you want to use a thinner syrup. I think I'll take a couple more questions here. We still have some time, but I don't want to prolong it too much. Here's a question: would 2 shallow supers be enough to get through winter? So by that, do you mean having a standard deep box and then 2 shallow frames of honey on top of that, or are you saying that the colony itself is only in a box consisting of 2 shallows? Give her a chance to. Okay, yeah. So if those 2 shallow supers are full of honey, that in this neck of the woods, that usually should be plenty. Again, because in that deep box there should be peripheral honey in those frames as well. So I'm assuming that that they're not completely empty in the bottom brood box as well. But a shallow honey super, if it's totally full of honey, it's about 35 pounds worth of honey, and so one of those supers should be sufficient to be able to make it through a fairly mild winter. But again, winters vary, your bees vary. You know, the larger the cluster you have, the more honey they're going to consume. The warmer it is, the faster they'll go through their honey stores. You know, there are lots of variables that go into it. So yeah, so 2 shallow supers should be plenty to hedge against starvation over the winter. So how do you get the bees out of the shallow in the spring back into the deep? Well, that's a good point. You just need to keep track of where the queen is. And using a queen excluder here is a really good method of doing that. If you can go in and you can find the queen, put her down into the deep, and then place the queen excluder on top of that, place the shallow supers on top of the queen excluder, any brood that's in those shallows will hatch out, and then she won't be able to lay back into it, and now you have, you know, you've depopulated those supers of the brood. If you can't find the queen, you can place the queen excluder between the shallows and the brood box anyway, and then go back in 3 to 4 days later. If you see eggs up in the shallows, then that means she's still up there. If you don't see eggs up there, but you do see eggs down below, then you know that you've captured her down below the excluder. So I'd like to thank everybody again for your attendance. I thought that this went exceedingly well. You know, again, I apologize for not being able to interact with you and take all of your questions. For those of you that are participating as a group, if you want to continue the discussion and you want to be able to badmouth me behind my back and say that my answers were very bad, this is a great time and a great opportunity to do it. But again, thank you very much, and I look forward to seeing you next time at the next webinar in June. Thanks again.